The human brain is an amazing structure. This 3-pound squishy thing that sits in your head can manage large amounts of data that even the big computer warehouses are unable to store. But for a long time, we were unable to fully understand how this machine works at processing things like emotion, intelligence, or consciousness, because we couldn't see the brain function live. Well, today, with the developments in technology and a better understanding of physics, scientists have managed to develop a device that can allow us to do just that. This device is called Functional Magnetic Resonance Imaging, or fMRI. With fMRI, we are now able to find new ways to treat mental illnesses and understand how the brain does what it does. So how exactly does fMRI work? To understand this, the basic principle you gotta remember is that when you show changes in behavior, the blood flow around your brain changes, with some parts getting more blood than others. fMRI basically uses MRI and a concept called bold imaging to create a map of how the brain is working. Let's first get a quick understanding of how MRI works. So, suppose you have a compass needle or a magnet and it's not in this container. Now, in the presence of Earth's magnetic field, the needle is going to turn with the north side facing the north and the south side facing the south, and it's going to become stable. Now, suppose I flip the needle to point in another direction. It's going to want to move back into its stable alignment, but it's currently unstable and full of energy. So when I let go of it, it's going to rotate back and release that energy it stored. Now, in your body, you've got a lot of hydrogen atoms in your tissues. These hydrogen atoms work just like the compass needle I was talking about. I first create a magnetic field of about 1.5 to 3 Teslas, and that will make the hydrogen atoms align to the magnetic field. If I send in a bit of energy, which in this case is called radio frequency pulse, I can make the atoms point in another direction and become unstable. When I stop providing the radio frequency pulse, the atoms will release their stored energy and return to their original alignment. If I place a detector near the person and can detect this energy release from the atoms, then I can create a picture of the body, and this picture is basically your MRI scan. Now, we've talked about MRI, but what is fMRI? Well, it's pretty much the same concept, but with a little extra thing called BOLD, or blood oxygen dependent imaging. BOLD imaging is based on the idea when your brain is doing different activities, the blood flow changes with oxygenated blood going more to some parts and less to others. In 1990, 3 papers were published by a man called Seiji Ogawa, which basically explained that the hemoglobin in blood has different magnetic properties. When hemoglobin is deoxygenated, it becomes attracted to the magnetic field, and when it's oxygenated, it becomes repelled by the magnetic field. So when the brain activity changes, more oxygenated hemoglobin goes to some parts of the brain and there's a change in the magnetic activity, which we can detect by MRI. This essentially is what fMRI is. We can see how the blood flow changes and create a map which we can use to figure out what the brain is doing. Now that we know the basics of fMRI and how it works, let's look into its applications. fMRI is still a relatively new concept and we don't know everything about how it could help us yet. Well, so far, it's being used in a lot of clinical research, but it's also starting to be used in hospitals as well. In clinical research, scientists are using fMRI to compare functionings of normal versus a diseased or injured brain, but they do this by comparing regions of the brain that are related to actions like speaking, planning, moving, or sensing. fMRI is also being used to detect brain tumors, stroke, or head injury, or even to detect conditions like Alzheimer's disease. There are also studies that use fMRI as a tool for drug development, also referred to as pharmacological fMRI. This is possible by administering a drug to the patient and then checking how much of that drug penetrates the blood-brain barrier and how the brain activity changes in response to the drug. How cool is that? Now, I mentioned that fMRI is also being used in hospitals. It's not really that popular, but doctors and surgeons are using this imaging in pre-surgical planning, which is pretty effective because when you're doing brain surgery, you don't want to mess up because the brain is really complex and even the smallest mistakes can affect normal functioning. Let's see an example of how fMRI is used in clinical operation. So this is actually a true clinical case study published in a radiology journal, and basically it talks about a 22-year-old patient who admitted to alcohol and cannabis use and had a history of focal seizures. After an MRI, the doctor found a T1 hypointense, T2 hyperintense lesion, which was a tumor in the left frontal parietal area of the brain, and it was located really close to the primary motor cortex. So, to safely cut off the tumor, the doctor referred for an fMRI of the patient to create a brain map. They made the patient perform different motor activities and then used the info to make the map. So this is what an fMRI data looks like. You can see the tumor represented by the pink region located medially on the brain. The red, blue and green regions located laterally and posteriorly to the tumor represent the brain lighting up during motor activities. The doctors used this to create a tumor resection map, and the patient had a safe operation and could leave the ward unassisted. This just shows how fMRI is so helpful in neurosurgery and how it's helping surgeons to do their job even better. Finally, fMRI is a great technology, but at the same time, there are really big issues. I didn't mention this earlier, but fMRI is also being used in neuromarketing and lie detection, where businesses are trying to look into people's brains to see how they feel about a product or whether they are lying, and a lot of people feel that this is unethical. There was also a study where fMRI was done on a dead salmon, and they found brain activity, which is just weird. Well, this just means that even fMRI can make mistakes. It is an awesome technology, but we still need researchers to make corrections to data so that it can model the reality better. But otherwise, that's it from me. Thanks for watching.